let's go ahead and for those who are finished gluing, let's go ahead and start talking about these properties that you guys glued into your flip books. I didn't have you write them in your flip book. I typed them out. So we're going to go ahead and write them to glue into your notes for your notebook here. So there's some super important properties that you guys need to know. Some of these are going to be familiar. You've heard before. Some of them are brand new. They're all really pretty simple. The first one we know well. We use all of the time, and it's actually 4 properties kind of combined in a way into one. And this is the addition, subtraction, multiplication, and division properties. I should have had of equality at the end there, but I forgot to do that. But these are the properties that you use to solve equations. So anytime you add the same number to both sides to solve an equation, that's the addition property of equality, or if you subtract the same number from both sides, okay? So what that property looks like, okay, let's start with kind of our statement. If A equals B. Okay, so we got this property. If A equals B. The addition property of equality says that A plus C would equal B plus C. I can add C to both sides of that equation, and it works, okay? The subtraction property of equality says A minus C equals B minus C. You can subtract the same number from both sides. The multiplication property says A times C equals B times C. And the division property of equality says A over C equals B over C. These properties we are going to use a lot. And these ones you hopefully won't have to reference because we use them so much, right? If you're ever adding something, and keep in mind, it doesn't have to be a number, okay? Actually, whenever we start with proofs, it's usually not a number. You can add the same thing to both sides of an equation. You can subtract the same thing, multiply by the same thing from both sides, okay? Okay, the next property is like the most obvious property in the world. It's so obvious, it's like a reflex. It's called the reflexive property. So obvious. Connection there. Okay. The reflexive property says A equals A. A equals A. Okay. Yeah, that's it. Okay. And it seems so obvious, like, why do we need to write that down? There's uses, okay? I promise you, we'll see it today when you use the reflexive property, okay? We have the symmetric property, which I think is also kind of easy to remember. The symmetric property says if A equals B, then B equals A. And we know that, right? It doesn't matter which side of the equal sign things are on. It means the same thing. Okay, now we have the transitive property, which I think is new, but it kind of reminds me of the law of syllogism. Okay, see if it reminds you as well. The transitive property says this. If A equals B and B equals C, then A equals C. So it kind of connects two statements. We have A equals B, well then B equals C. But if A equals B and B equals C, then A has to equal C, right? You can connect the first and the last one. That's why it kind of reminds me of that law of syllogism there, okay? The substitution property should be familiar as well. The substitution property we used last year in Algebra 1. The substitution property says if A equals B, then B can replace A. If A equals B, then B can replace A. Whether it's a number, a segment, anything, okay? Those can replace each other. Okay, and then the distributive property, we're really familiar with this as well, right? If you have A times the quantity, B plus C, you can distribute the A and get AB plus AC. Distribute out that A. Okay, now, the reflexive properties of congruence, symmetric property of congruence, and transitive property of congruence is basically the reflexive, symmetric, and transitive property, but instead of an equal sign, it's going to be a congruency symbol because these are talking about segments and angles, okay? So these can get a little wordy here, okay? So the reflexive property of congruence every segment is congruent to itself. And every angle is congruent to itself. Angle A is congruent to angle A. Every angle is congruent to itself. Okay, and we have the symmetric property of congruence, which says if segment AB is congruent to segment CD, then segment CD is congruent to segment AB. Just like an equal sign, you can flip it around, it reads the same thing. Okay? And you can do the same thing with angles. So if angle A is congruent to angle B, then angle B is congruent to angle A. Once again, it doesn't matter which side of that congruency symbol it's on, it still works. Okay, and then the transitive property of congruence. I'm going to warn you, it gets a little wordy. Okay, but it does the same thing. The transitive property of equality, if A equals B and B equals C, then A equals C. It does the same thing. It connects these two separate statements, okay, into one statement here. So let's start with the segments. Okay, so we have if segment AB is congruent to segment CD, and segment CD is congruent to segment EF, then you can connect the first and the last together. Segment AB is congruent to segment EF. AB is congruent to CD, and CD is congruent to EF. Well, then AB would have to be congruent to EF. And then you can do the same thing with your angles. So, if angle A is congruent to angle B, and angle B is congruent to angle C, then angle A is congruent to angle C. Like I said, those ones are pretty wordy, just with the angles, congruence, segments. Okay, but those are the same properties that you guys glued into your flipbook. We're going to need those today. Okay. Now with the UNO proofs yesterday, we kind of got a little introduction into what proofs are without actually using math. So today we're going to start looking at proofs that are math related. So they may not necessarily be geometry related. They may just be like an algebra problem. But what we're going to see today is we're really going to see the whole reason why your math teachers, whether it was me or your other math teacher last year, said you have to show your work, okay? You're going to really see why that was important, because now whenever we get into geometry, you're going to have to say, well, here's what I did, right? And if you're not used to showing your work and thinking through those things, this might be kind of challenging, okay? I think they're super fun, of course, because they're math. All math is fun, okay? But we talked about yesterday, okay, a proof, it's a convincing argument that uses deductive reasoning. Today we're going to talk about a two-column proof. Remember, a two-column proof, like we saw yesterday, the statement is on the left, which is what you put the cards on the left, right? Here's how I get from the given card to the final card. And then the reasons were on the right. So it's either the same color, the same number, or I changed the color, okay? So some tips for writing a two-column proof, okay? And we're going to be doing this a lot this year, so I think these are going to be pretty handy, okay? So some tips for writing a two-column proof. First thing, okay? You need to number each step. What I mean by that is whenever you're starting your proof, you're going to have your statements, you're going to have your reasons, and then you're going to have statement 1 and reason 1. Okay, you're going to have statement 2 and reason 2, and they should match each other. Okay? You are always going to start with the given statement. I don't care if it's with UNO cards or if it's with an algebra problem or if it's with a geometry problem. You're always going to start with the given statement. We're we're going to see today that sometimes you have statements, you have two statements, but they're going to have the same reason. That you're going to say, okay, I can do this and this. I can also do this. It's all because of the same reason. You can put it in the same step. Okay, you don't have to come up with two separate steps that have the same reason. You can combine that in the same step. I find it very helpful to label the diagram with the given information. Sometimes you're given a diagram to help you with your proof. Okay, now, the order of the statement that's not always fixed, and we saw this yesterday, that as I was grading your guys' Uno proofs, some of you guys had different answers, and they were correct, that there were different ways on some of the problems to get from the given card to the final card, okay? And it worked, okay? Because it made logical sense that it either had the same number or the same color, okay? But you couldn't have a different order if it didn't make logical sense. So if in the middle you had a blue 0 connected to a red 4, there's no logical way I can connect those together. So the order of the steps isn't necessarily fixed, okay? As long as it makes logical sense. Okay, now I mentioned this, okay? That reasons column, okay? And this is the part I think that's probably the challenging part. That I think we're really good at like figuring things out and figuring out how to get from the first to the last. But explaining why and why we're able to do that, that's the challenging part, the reasons part, okay? So your reasons, guys, are always going to be postulates, theorems, definitions, or properties. Postulates, theorems, definitions, or properties. Now the definitions, this could be anything like, well, they're complementary angles, so they had to get 90. That's the definition of a complementary angle. That would be a reason. I know they equal 90 because the definition of a complementary angle is they had to give me 90, okay? But the postulates, the theorems, and the properties, where are you going to find those? Your flip book, right? That's what we've been kind of adding to since chapter 1. You're going to need some of those today, okay? Now, this is the part that I don't think I'm going to have a problem with you guys, because we all love doing this. We are going to use symbols and abbreviations for words whenever you can within your proofs. So we're probably not going to write out the addition property of equality. We're going to write add prop of equal. Okay? You don't have to write it all out. You don't have to write out the word congruent. You can write out the congruency symbol. So anytime you can, use symbols or abbreviations. Okay? All right, let's get this glued in, and then we are going to look at 3 proofs. So this should be page 27. And this is 2-5, and it's reasoning in algebra and geometry. Okay, so we're going to fill in the reasons that justify each step. So they're going to fill out a good chunk of the proof for you, okay? So we're going to start our 2-column proof. Your 2-column proof is always going to look like this. You're always going to have your statement column, and then you're always right next to it going to have your reasons column. Okay? Now for today, they're going to fill out the whole statements column for you. You don't have to come up with any of the statements, okay? But you are going to have to kind of decipher the statements and figure out, well, how are they coming up with this? What are they doing? Because that's how you're going to come up with the reasons. Now remember, you always want to number them. So they're going to do this for you, but kind of get in the habit here. So the first statement, okay, they're not going to start with a given and then approve this because this is an algebra problem. The first statement's going to be an equation. 2 times the quantity 5x plus 1 equals 42. Okay, the second statement is going to be 10x plus 2 equals 42. The third step is going to be 10x equals 40. And the fourth step is going to be x equals 4. Okay, so this is what you're going to be given, right? This is what you're going to see in your homework when you open your textbook, okay? The first problem is going to be pretty similar to this, okay? So what you have to do is you have to give me the reasons. So you number the reasons as well, and they should correspond to each other, okay? The first reason, and I don't care if it's an algebra problem, I don't care if it's an UNO proof, I don't care if it's a geometry problem, what is always your first reason? Given. Every single time. That is your given. Okay? Now the second reason needs to tell me, how did I get to step 2? How did I get from the given to step 2? And you kind of just got to observe, okay, well, what happened? Okay, we distributed the 2, right? And we did that because of the distributive property. Remember, your reasons need to be postulates, theorems, definitions, or properties. Okay, step 3, you need to say, okay, how did I get to step 3? From step 2 to step 3, what did they do? Okay, they subtracted the 2, right? What property tells me I can subtract 2? The subtraction property of equality. So subprop of equal. Remember, you can abbreviate there. And then your fourth reason is, how do you get to step 4? To get from 10x equals 40 to x equals 4, what did they do? Divide by 10. What property says you could divide by 10? The division property of equality. Okay, so that would be an example of an algebra proof. Not too bad, right? Okay. Let's look at one that maybe has a little more geometry. Okay, so this one's going to start with this. This one's going to start with a given. Okay, we're given that the measure of angle ABC equals, not 180, equals 80. Measure of angle ABC equals 80. And then we're also going to have a picture. Okay, so your picture, we have got this angle, a ray, and somewhere in between the angle. I don't know it's the bisector unless they tell me that. I don't know it's a bisector. Okay. We're going to have point A here. B is going to be that shared vertex. C will be that point here. And D will be right there. And then they'll give me a couple of expressions. So we have 3x plus 3, and then this one is 6x plus 5. Remember, even if those angles look like they're congruent, unless they tell you that, you cannot assume that. Okay? Okay, so that's the given information. And you may already in your head kind of be thinking how you would solve this, okay? Which is what they're going to do as they go through the proof. So, in your proof, okay, we're going to have our statements and our reasons. Statements and our reasons. And remember, they're going to give you all of the statements. I'll kind of talk through them a little bit, but they're going to give you these. The first statement is always the given. So this one would be the measure of angle ABC equals 80. Okay. I'm going to go ahead and we'll write down all of the statements and then we'll go back and give the reasons. Okay. The second statement says measure of angle ABD plus the measure of angle DBC equals the measure of angle ABC. The measure of angle ABD plus the measure of angle DBC equals the measure of angle ABC. That's their second statement. Okay, the third statement says 3x plus 3 plus 6x plus 5 equals 80. The fourth statement says 9x plus 8 equals 80. The fifth statement says 9x equals 72. And then the last statement says x equals 8. So once again, these are the ones they're going to give you. This is everything that you would be given on your homework. You got to come up with the reasons. And I think they kind of fill in some of the reasons for you. But we're going to come up with all of them because it's so fun. Okay. So my first reason, how do I know that the measure of angle ABC is 80? It's the given. Always going to be the given. Okay, number 2. So here's where, remember, it's either going to be a postulate, a theorem, a definition, or a property. So they're saying that the measure of angle ABD, the measure of angle ABD, so this angle, plus the measure of angle DBC equals the measure of angle ABC. They are saying that if I take this angle plus this angle, I get the big angle. That sounds familiar, right? From chapter 1. We did that. It was a postulate in chapter 1. We need to figure out what postulate from chapter 1 says I can take this angle plus this angle to give me the big angle. It's the angle addition postulate. Good. So sounds familiar, just gotta know where to look. Okay, now, from step 2 to step 3. This is the one I think that we're gonna see this a lot, okay? But kind of getting the hang of this, okay, is gonna be the one that's kind of tricky. So they go from, okay, well I can take this angle plus this angle and give me this, to, well, 3x plus 3 plus 6x plus 5 equals 80. What did they do? They did the same thing though, didn't they? You're exactly right. They took this angle plus this angle to give me the big angle. Why am I allowed to do that? Yes! Substitution! Right? Because the measure of angle ABD is 3x plus 3. So I can use 3x plus 3 instead. So that's the substitution property. Very good. Okay, well from step 3 to step 4, what did they do from step 3 to step 4? Really just combine like terms, which actually is the distributive property. But if you just want to say combined like terms, I'm good with that, because we don't usually associate it with the distributive property, even though it is, okay? We'll just call it combined like terms, okay? From step 4, after we combine like terms, to step 5, what property did we use? Step 4. Subtraction, very good. The subtract, because we subtracted 8 from both sides, so this is the subtraction property of equality. And then lastly, to get to step 6, we divided, which means the division property of equality. So a couple tricky things to look for there. I think the substitution, once you start seeing it, it's easier to recognize. But that substitution can be a little sneaky sometimes. Okay? Questions on that second proof? I got one more. And this one, there's a couple steps of this that can be a little tricky here. Okay, so number 3. Okay, this time we're going to be given that measure angle 1 equals the measure of angle 3. We want to prove that the measure of angle AEC equals the measure of angle DEB we want to prove that the measure of angle AEC equals the measure of angle DEB. We'll have a picture again. Okay, so we're going to have kind of a bigger angle this time. We're going to have two rays. Okay, so 4 total rays here. We're going to number the points, just going left to right across, as A, B, C, D, and then that shared vertex is going to be E. And then we'll number the angles as well. So left to right will be angles 1, 2, and 3. Now, one thing in that tips is, I said, one thing I find really helpful is label your diagram with your given information if possible. Sometimes there's nothing to label, but this time it is. It says, I'm given the fact that the measure of angle 1 equals the measure of angle 3. So the measure of angle 1 equals the measure of angle 3. They're congruent, right? So I could mark that on my diagram so I can kind of see that they're the same thing. Okay? All right, now let's set up our proof. Okay? So we have our statements and our reasons. Statements and our reasons. Okay, the first statement, it will be given to you, but we should already know it, right? Okay, the first statement's going to be the measure of angle 1 equals the measure of angle 3. Okay, my second statement is going to say the measure of angle 2 equals the measure of angle 2. My third statement says the measure of angle 1 plus the measure of angle 2 equals the measure of angle 3 plus the measure of angle 2. Okay, the fourth statement is actually going to have 2 steps in one. Remember how we talked about if you have 2 statements that have the same reason, you can combine them in one. This is going to be an example of that. So these are going to have the same reason, okay? It's going to say this, the measure of angle 1 plus the measure of angle 2 equals the measure of angle AEC. And then the second statement in step 4 is going to say the measure of angle 3 plus the measure of angle 2 equals the measure of angle DEB. And then finally, the last step is going to say the measure of angle AEC equals the measure of angle DEB. So this is the trickiest of all of them for sure. Okay? Okay, but the first step should be easy, right? What's my first reason? It's given. Yeah, it's always given. So even if you have nothing else that you know how to do, you always know the first reason. Okay, it's always the given. Okay, number 2, even if you don't know why they're doing this, the second statement says measure of angle 2 equals measure of angle 2, which seems so silly that I don't even need to say it. But how do I know that the measure of angle 2 equals the measure of angle 2? Yeah, the reflexive property. You don't really have to understand yet why we're doing that. You just got to know why. Yeah, the reflexive property says that. Okay, now this one you kind of have to pay close attention here. Number 3 says measure of angle 1 plus the measure of angle 2 equals the measure of angle 3 plus the measure of angle 2. Do we have any ideas what's happening here? I want you to kind of look at maybe the first step. See how the first step says the measure of angle 1 equals the measure of angle 3? The third step says the measure of angle 1 plus the measure of angle 2 equals the measure of angle 3 plus the measure of angle 2. What changed? I guess it kind of skipped from step 1 to step 3. What did they do, Elijah? This isn't going to be the transitive property. I don't think we're going to see that today. So if number 1 says measure of angle 1 equals measure of angle 3, okay, we've got 1 and 3. Step 3 says 1 plus 2 equals 3 plus 2. What did they do? Okay, they added the measure of angle 2 to both sides. Do you guys see that? I know it's kind of hard to see sometimes, right? Because there's a lot of m's and angles and stuff. But they took the measure of angle 1 equals measure of angle 3, that first statement. They really just added these together, right? Measure of angle 1 plus the measure of angle 2 equals the measure of angle plus the measure of angle 2. This is the addition property of quality. That's all that is. Like I said, it's not always a number. Actually, most of the time it's not going to be a number in geometry. It's going to be an angle or a segment or something like that. But you can add the same thing to both sides. Okay. Now number 4 says the measure of angle 1 plus the measure of angle 2 equals the measure of angle AEC. Well, that sounds familiar. I feel like we just did that, didn't we? What tells me I could take angle 1 plus angle 2 and give me the big angle? Yeah, the same one as the last one, right? That's the angle addition postulate. And notice, I don't have to have another reason because it's the same thing, right? Because you can say, well, the measure of angle 3 plus the measure of angle 2 equals the measure of angle DEB. It's the same thing, right? These two angles added together give me the big angle. Okay, everyone with me so far? Okay, now this last one, can be kind of hard to see here, okay? So then they get to the conclusion. They say, oh, well, then measure of angle AEC equals the measure of angle DEB. Okay? So they went from saying, okay, the measure of angle 1 plus the measure of angle 2 equals the measure of angle AEC, and the measure of angle 3 plus the measure of angle 2 equals the measure of angle DEB. Now, last class, and I know what you're going to want to say, I think you may be thinking transitive property. The transitive property, what it would have to say, the transitive property either says A equals B and B equals C, then A equals C. Or the transitive property could also say if A equals B and C equals B, then A equals C, right? If two things equal the same thing, and that's not exactly what this is saying because angle 1 and angle 2, angle 3 and angle 2, those are different, but these aren't the same. These could be different, but those would have to be the same. So it's not the transitive property. Anybody have a guess? And it's not the symmetric property. The symmetric property has to be the exact same thing on both sides. It just is flipped. This is the substitution property. What they're doing here is they said in step 3, the measure of angle 1 plus the measure of angle 2, right? I can take angle 1 plus angle 2, it equals angle 3 plus angle 2. But here's the thing. Measure of angle 1 plus measure of angle 2, we said in the next step, is the measure of angle AEC. So I can substitute the measure of angle AEC in for the measure of angle 1 plus the measure of angle 2. And I can do the same thing here. So that's going to be the substitution property. The substitution property is kind of the sneaky one, okay? So if you're really running into a wall and you can't figure out what it is, it may not be your solution, but it sneaks in there a lot, the substitution property.